This video is about proving that lines are parallel. In our last section, we looked at a postulate and 3 theorems, and in this section, we're looking at the converse of that postulate and those 3 theorems. You should be able to prove these theorems and be able to prove other theorems that use these theorems. So here are the theorems from our last section, and notice the pattern that if the lines are parallel, then the corresponding angles are congruent. Or if the lines are parallel, then the alternate interior angles are congruent. Now, if we found the converse of these, we would switch this and this. And so it then would say, if the corresponding angles are congruent, then the lines would be parallel. That you would be the conclusion part of our statements would be then the lines are parallel. So we'll look at the converse of these of this postulate and these 3 theorems, and that's the focus of our study in this section. So the converse of the corresponding angles postulate says if the corresponding angles are congruent, then the lines are parallel. And just like in the last section, this is a postulate, so it doesn't need to be proven. We're going to take it to be true without a proof, and we can prove the other ones from this one. The converse of the alternate interior angles theorem says if the alternate interior angles are congruent, then the lines are parallel. The converse of the same side interior angles theorem says if the same side interior angles are supplementary, again this is the different one, then the lines are parallel. And our last one, the converse of the alternate exterior angles theorem says if the alternate exterior angles are congruent, then the lines are parallel. Make sure you have all 4 of these in your notes because they're pretty important. Now, are the following lines parallel, and if so, why? Okay, if angles 4 and 6 are congruent, then yes, these lines would be parallel, and the reason is the converse of the alternate interior angles theorem. Okay, this next one. Given that angles 3 and 6 add to 180, are the lines parallel? And the answer is yes. Okay, 3 and 6 are same side interior angles, so by the converse of the same side interior angles theorem. Okay, next, find the value of x for which L and M are parallel. Well, for L and M to be parallel, these corresponding angles would have to be congruent. So 55 would have to be equal to x plus 25, and I simply solve this equation by subtracting 25 from both sides to get x by itself. And I get 30 is equal to x, or x is equal to 30. Now let's move into proving some of these theorems. Okay, let's prove the converse of the alternate interior angles theorem. So we'll start with our given. We always start with the given. And we use deductive reasoning to explain why this is always true. Okay, now why should L and M be parallel? If we start with angles 4 and 6 being congruent. Okay, now you may want to say, well, it's because of the converse of the alternate interior angles theorem, but we're proving that theorem, so we can't use it in our proof. But we can use our postulate. We can use that if 2 and 6 are congruent, then the lines would be parallel. Okay, but we don't yet know that angles 2 and 6 are congruent. So I will start with our given, 4 and 6 are congruent. Okay, there's nothing else I can tell from that, but looking at our picture, we notice that angles 4 and 2 are vertical angles. So I know that angle 4 is congruent to angle 2 because they're vertical angles by the vertical angles theorem. Okay, and because of this statement and this statement, And because angle 6 and angle 2 are both congruent to angle 4, then I know that angle 6 must be congruent to angle 2, and that is by the transitivity property of congruence. Now that I have angles 2 and 6 being congruent, my corresponding angles are now congruent. I can now say that L is parallel to M by the converse of the corresponding angles postulate. Okay, and that's it. So our last theorem, we're going to prove the alternate exterior angles theorem. Again, we'll start with our given, work down to our prove statement. We're given that angles 1 and 7 are, are congruent. Again, looking at this picture, we can see that angles 1 and 3 are, so we're going to use this. We can see that angles 1 is congruent to angle 3 because they are vertical angles. Okay. Now, since angle 7 and angle 3 are both congruent to angle 1, these two statements tell me that angle 7 must be congruent to angle 3, again by the transitivity property of congruence. I'll abbreviate postulate of congruence. Okay, now that our corresponding angles are congruent, this tells me that angle L must be parallel to angle M by the converse of the corresponding angles postulate. Okay, and that's our proof. This video was about the converse of our postulate and our three theorems and proving that lines are parallel.